All right, so what we're going to do is just kind of pick up where we left off. We are halfway through the notes 11-2. We're on probability distribution, and this is a specific type, which is your binomial experiment. We've got our four conditions of a binomial experiment. You have to have a fixed number of trials. Each trial has to have two possible outcomes. The probability of success can't change from one trial to the next, and the random variable represents the number of successes. So we're just going to decide if these are binomial or not. So the first one says the result of a survey indicates 65% of couples have two or more jobs between them. A group of 50 couples are surveyed on whether they have two or more jobs between the two of them. The random variable represents the number of couples who have two or more jobs. So let's see, we've got a fixed number of trials because they surveyed 50 people. We have two outcomes. Either they have two or more jobs between them or they don't. So P and Q, we've got those. We've got the probability of success is the same. So 65% is the probability of success. It doesn't change from one couple to the next. Just it's a 65% probability of success, which means we've got a probability of failure of 35. And the X, they'd say, represents the number of people who have two or more jobs. So, yes, that one is binomial, because it met those conditions. Now, it does say list all possible values of the random variable. Well, X just says you could have one couple that has two or more jobs. We could have two, we could have 3, 4, all the way to all 50 of them. Okay, next one, we've got 10 blue chips and 5 red chips are placed in a hat and shaken. 3 chips are drawn from the hat, one at a time, without replacement. The random variable represents the number of blue chips that are drawn. All right, so how many experiments are we doing? We can't do more than 15 because there's only 15 red chips, and we're not putting them back in. Okay, so N is 15. Do we have a P and a Q? Looks like P is the number of blue chips. Okay, so Q would be not getting a blue chip. Probability of success, well, for that first draw, it would be 10 out of 15, because 10 blue out of 15 total. But since we're not replacing it on the second draw, there would be less than that. There'd be like 9 out of 14. So what that says is we don't have a probability of success that's the same for every trial. So no, this is not binomial. Okay, so that's how we can look and see if they're binomial or not. This should give you good reason. Probability of success is not the same for every trial. Okay, now this is the formula for binomial probability. It is a combination. And of course, these only work if you've got a binomial experiment going on. So our example on this one is going to be about college. A recent survey of high school seniors indicated that 78% of students plan to attend some type of formal training or college after school. 4 seniors are randomly selected and asked if they plan to receive formal training or attend college after high school. Construct and graph a binomial probability distribution for the random variable X representing the number of seniors who said yes. Then find the probability that at least 3 of them said yes. Okay, so this is a binomial. We have 4 as our N. We have a P and a Q. P is some kind of plans after high school. Q is not having plans. Our probability of success appears to be 78%. So yes, this is binomial. So what we need to do to make a probability distribution, we need to find the probability that they have plants. So 0, 1, 2, 3, and 4. So let's say we want to know what's the plan that none of them are doing anything after high school. So we would use 0 as the x, and n, of course, is our 4. So 4, C0. P is 0.78, because that's the probability of success, to the 0. Just looking at the formula up here, we've got p to the x. Okay. 1 minus point, because q would be 1 minus p, so 0.22. 4 minus 0, n minus x. So you'd put that in the calculator, and we've got 0.002343. Okay, so that's what we would do for each of these. We would put in our new x value. We'd leave the 4s as they are, because that's our n, all the way through. And here's what we end up with. I'm just going to fill this in real quick. I will make sure there's a filled-in copy of these notes online already for you, so that you can just refer to them as you're working on the homework paper. Okay, so that's just the probability of each of those occurring. Now we do need to make a graph. Looks like my highest probability is 0.4 here, so I'm just going to say 0.1, 0.2, 0.3, 0.4. And we've got 0, 1, 2, 3, 4. Okay, the probability that 0 people of those 4 said yes is 0.002. That only 1 did was 0.03. 2 would be 0.17, so it's going up a little. 3 is 0.417. And 4 is 0.37. Okay, so there we go. Kind of fits in pretty well with our 78%, because our highest is there at 3 and 4 there, so that shows us around 78% of our data would fall right there. And it says, let's see, finishing up, I've got find the probability that at least 3 of them said yes. So the way we'd write that, we'd say the probability that x is at least 3. So that means greater than or equal to 3. So all we're going to have to do is add those two together. The probability that we had 3 and probability that we had 4, which gives us 0.787756. So it's a little bit more exact than what we got from the problem, but it's still right there at 78%. Okay. Now we do have formulas for mean, standard deviation, and variance. These are actually a bit easier to use than those that we had before. You'll see that mean is NP, variance NPQ, and standard deviation is still the square root of the variance. You could still use those other formulas. You'd get pretty close answers. These are a little bit easier, so I'd recommend using these. All right, so to get our mean, NP. And this is the same example with these 4 high school seniors that we've chosen. Okay, so our N is 4. And P is the probability of success. We wrote that down up there at 0.78. So we just multiply those together and we get 3.12. So of those 4, chances are 3.12 of them would say they do have college plans. Variance is NPQ. So that's 4.78. And then Q is 0.22. That's our 1 minus 0.78. Which is 0.6864. And then standard deviation is the square root of NPQ. So the square root of 0.6864, which is 0.828. I'll say 5 there. Okay. So that's telling us that on average, 3.12 of 4 seniors would say they've got plans, and it's spread out by about 0.6864, and most of our data is going to be right close to our 0.3, 0.12 plus or minus 0.8285. Okay? All right, so that should finish up the section, and you should be able to finish the homework worksheet that I gave y'all yesterday. Okay, today I did leave you some probability practice. We've got some blue cards and some white cards. Do make sure that those get turned back into the sub before you leave today. You will be filling in this page. Make sure your name is on it, please. And we're just practicing probability. This isn't going to be any permutation or combinations. It's just going to be probability practice. Don't forget, tomorrow you do have a quiz. They are going to be permutation and combinations on there. You'll be using your calculator, and it is open note. Okay, so what you're doing on these, we've got what is the probability that a coin will land on heads and then a coin will land on tails. So the first thing the paper asks is that independent or dependent? So you have to figure out, does the second event depend on the first event? So if I flip the coin and it lands on heads, does that mean it's not going to land on heads again? No, it does not mean that. So we're going to write independent right there. Let's finish spelling that. D-E-N-T. Okay. So we've got a 1 in 2 chance that the first time it lands on heads, I think it was heads, and then we flip it again, and we've got a 1 in 2 chance that it lands on tails. So we've got 1/4, which is 0.25 and 25%. Okay, so that's how you're going to fill in this first one. You do need to watch out for words like putting it aside, because that means we're not replacing it, which is make it a dependent event. Like this particular one, let me do this one. We've got the tiles numbered 1 through 9. Probability of drawing the number 2 and then drawing the number 5. Okay, so to draw the number 9 or 2, we'd say 1/9. Yes. And then when we go to draw the second one, well, there's one less now. There's only 8 to choose from because that 2 is out. And one of those is a 5. Or, yeah. So you just multiply those 2 together. So you'd have 1/72. Okay. So that was number 4. So we'd say dependent there. One over 9, 1/8, which is 1/72. I think I said 74. Anyway, 1/72, and then you change that to a decimal and a percent. Okay, so that's how you're going to do those cards. I can't remember if they're blue or white right now. But yeah, so that's what you'll do on that. And you can work together. You can use your calculators, all that. Okay, on the other set of cards, we've got kind of more of an expected value type thing. I'm going to do this one for you. Carrie has a game that uses 20 tiles that are the same shape and size. We want to know the probability that the tile she chooses is a quadrilateral. So this is a vocabulary word. Quadrilateral means it's got 4 sides. So that means the rectangles and the trapezoids. Since they gave us those probabilities, what I'm going to do is I know that there's a 60% chance, because I just add the 20 and the 40 together, out of 20, that we have a quadrilateral when she chooses it. Okay. Okay, number 3, well, let me look at 2. Number 2, we've got 1/4 of the candy is caramel, 2/5 is chewy, and the remainder is chocolate. We want the probability that Donna will choose a piece of candy that is chewy, which is 2/5. Oh. 2/5. And then that she'll choose a piece that is chocolate. So we need to kind of figure out how much of it is chocolate. Probably what I would do is actually translate this into numbers somehow. Because we know that all the probabilities have to add up to 1. So 1/4 plus 2/5 plus x has to equal 1. So I'm going to need a common denominator. So 5, I'm going to give a denominator of 20. 8. So 7. Okay, so 7 out of 20. Okay, so we know that to get a chewy, we do 2/5. Now, to get a chocolate, there's going to be 1 less piece of candy, and I'm just assuming there's 20 pieces of candy because that seems to be working out for me to do it that way. So there's going to be 1 less, so we're going to do 2/5 times, let's do 6, 19. Okay, and you're going to multiply that together, and that'll give you your answer on that one. Okay. This one, we want it to land on not an even number and then a even number. So we count, there's 1, 2, 3, 4 odd numbers on there and 4 even numbers. So I'd say 4 out of 8 times 4 out of 8. Because they're independent events, so we're not going to need to worry about 1 less or anything. Okay, 4, you're doing the same way. You figure out which ones are integers and perfect squares. 5, probability that Tony will not spin red, then he will spin yellow, then he will spin red. So to not spin red, well, there's a 30% that you will, so I'm going to say 0.7 says you won't. Then yellow, well, 0.25, and then red. So you'll multiply those 3 together, and that will give you your probability. And I bet you can figure out number 6. Okay? So go ahead and work on that. You do have 2 worksheets due on, you know what, I'm going to change that to Monday. Both of those worksheets will be due on Monday, since there'll be quite a few of y'all gone on Friday afternoon, and since I'm gone this week. So we'll do that. We'll have both of those papers due on Monday. Remember, the next part of your project is due on Monday. You've got a quiz tomorrow, open note with calculators. So work on this paper, see how much you can get done. We'll just say it's due on Monday too. Okay, so everything's due on Monday.